What if I told you that AI just learned how to actually think through problems step by step, just like humans do? Today, we're diving deep into two revolutionary AI reasoning systems that are completely changing the game: OpenAI's O1 model and DeepMind's chain of thought reasoning. These aren't just faster chatbots. They're AI systems that can pause, think, reason through complex problems, and even correct their own mistakes. By the end of this video, you'll understand exactly how these systems work, see them in action, and know which one might be better for your specific needs. Let's jump in. First, let's understand what AI reasoning actually means. Traditional AI models like GPT-3 or even early GPT-4 worked more like incredibly sophisticated autocomplete systems. They predict the next word based on patterns they've seen during training. But reasoning AI is fundamentally different. It can break down complex problems into smaller steps, think through each step logically, and even backtrack when it realizes it's made an error. Think of it like the difference between someone who's memorized a bunch of math formulas versus someone who truly understands mathematical principles and can work through new problems from first principles. OpenAI's O1 model, released in September 2024, represents a massive leap forward in this reasoning capability. The O1 stands for Omni-1, and it's designed to excel at tasks requiring deep thinking, complex coding problems, advanced mathematics, scientific reasoning, and multi-step logical puzzles. What makes O1 special is its training approach called reinforcement learning from human feedback, combined with something called process supervision. Instead of just being rewarded for getting the right answer, O1 is trained to follow good reasoning processes. It literally learns to think before it speaks. Here's what's fascinating. O1 can spend significantly more time processing a problem before responding. While regular GPT-4 might answer in seconds, O1 might take 30 seconds or even minutes to work through a complex problem, showing its thinking process along the way. This chain of thought reasoning allows it to achieve PhD-level performance on physics, chemistry, and biology problems. On the other side, we have DeepMind's chain of thought reasoning, which takes a slightly different approach. Rather than being a single model like O1, chain of thought is more of a methodology that can be applied to various language models. DeepMind's approach focuses on explicitly teaching models to verbalize their reasoning process, breaking down problems into intermediate steps that humans can follow and verify. The key innovation here is something called constitutional AI. The model learns to critique and improve its own reasoning by following a set of principles or constitution. This makes the reasoning process more transparent and potentially more reliable. Let's see these systems in action with a real coding problem. I asked both systems to solve a complex algorithm challenge, creating an efficient solution for finding the longest palindromic substring in a given string. Regular GPT-4 immediately jumps to a solution, often using a brute force approach. But watch what O1 does differently. First, it acknowledges the problem complexity, considers multiple algorithmic approaches, weighs the trade-offs between time and space complexity, then implements an optimized solution using Maneker's algorithm. The reasoning process is visible. You can see it thinking through edge cases, considering performance implications, and even testing its solution mentally before presenting the final code. DeepMind's chain of thought approach shows similar depth, but with more explicit step-by-step verbalization. It might say, Step 1, I need to understand what makes a palindrome. Step 2, consider different algorithmic approaches. Step 3, analyze time complexity requirements. Step 4, implement and verify the solution. Both approaches significantly outperform traditional models on complex reasoning tasks. In mathematical problem solving, O1 scored in the 89th percentile on competitive programming problems, compared to GPT-4's 11th percentile. That's not just an improvement, that's a fundamental leap in capability. But here's where it gets really interesting for practical applications. These reasoning capabilities translate directly into real-world problem-solving scenarios. In software development, both systems can debug complex code by systematically working through the logic, identifying where problems might occur, and proposing targeted fixes. In scientific research, they can help formulate hypotheses, design experiments, and even identify potential flaws in research methodologies. However, these systems aren't perfect, and understanding their limitations is crucial. First, the improved reasoning comes at a computational cost. These models are significantly more expensive to run and slower to respond than traditional language models. OpenAI's O1 costs about 3 to 4 times more per token than GPT-4. Second, the reasoning process, while more reliable, can sometimes lead to overthinking simple problems. I've seen instances where O1 will spend considerable time reasoning through a straightforward question that GPT-4 would answer correctly in seconds. There's also the question of reasoning transparency. While we can see the output of the reasoning process, we don't fully understand how these models generate their step-by-step thinking internally. This black box nature remains a challenge for critical applications where full transparency is required. So which system should you choose? If you're working on complex mathematical problems, advanced coding challenges, or scientific research, OpenAI's O1 currently has the edge in terms of raw performance. Its integration with ChatGPT Plus makes it accessible for individual users, and the results on standardized tests are impressive. DeepMind's chain of thought approach shines when you need more transparent, explainable reasoning. If you're in a field where you need to understand and verify the AI's thinking process, like education, legal analysis, or medical research, the explicit step-by-step approach might be more valuable. For developers, both systems offer APIs, but O1 has better documentation and community support at the moment. DeepMind's approach is more research-oriented and might require more technical expertise to implement effectively. Looking forward, this is just the beginning of the reasoning AI revolution. Both OpenAI and DeepMind are reportedly working on even more advanced reasoning systems. We're likely to see improvements in speed, cost-effectiveness, and reasoning capability over the coming months. The implications are enormous. We're moving from AI that can generate human-like text to AI that can actually think through problems like a human expert. This could accelerate scientific discovery, revolutionize education through personalized tutoring that can reason through student misconceptions, and create AI assistants that can handle complex, multi-step tasks reliably. If you want to try these systems yourself, here's what I recommend. Start with OpenAI's O1 through ChatGPT Plus for around $20 per month. Try giving it complex problems in your field, coding challenges, mathematical proofs, or analytical questions that require multi-step reasoning. Pay attention to how it breaks down the problem versus how regular GPT-4 approaches the same question. For DeepMind's approach, you can experiment with their research demos and papers available on their website, though full access requires more technical setup. The future of AI isn't just about generating more human-like responses. It's about creating systems that can truly reason, think, and solve complex problems alongside us. OpenAI's O1 and DeepMind's chain of thought reasoning are the first major steps into this future, and honestly, I'm incredibly excited to see where this technology goes next. What problems would you want to solve with reasoning AI? Let me know in the comments below, and if this video helped you understand these breakthrough systems, hit that like button and subscribe for more deep dives into the latest AI developments. Until next time, keep exploring the future.